Once we can factor polynomials completely, we can write the least common multiple of two polynomials. How? Let's suppose we wanted to find the least common multiple of the polynomials x squared minus 4x plus 3 and x squared minus 9. Well, just like numbers, we would begin by factoring them into primes. X squared minus 9 is a little bit easier. It's a special form. X squared minus 9 is x minus 3 times x plus 3, noting that 9 is 3 squared. X squared minus 4x plus 3. Well, we'll want to split up that middle term with two numbers whose sum is negative 4 and whose product is positive 3. I think we'll have negative 1x and negative 3x. Greatest common factor of this row is x, of this row is 1. X times what gives me x squared? X times x. Is x times 1 going to be negative 1? X? No, this is going to have to be a negative 1. X times what gives me negative 3x? X times negative 3 gives me negative 3x. Negative 3 times negative 1 is positive 3? Yes, it is. So I have x minus 3 times x minus 1 as my factors. All right. What does this mean? Just like numbers, polynomials factor uniquely into primes. What does that mean? That means if I have any multiple of x squared minus 9, it has x minus 3 as a factor and x plus 3 as a factor. If I have any multiple of x squared minus 4x plus 3, it has x minus 3 as a factor and x minus 1 as a factor. So I can use this to build my LCM. So in this example, my least common multiple, it needs to have an x minus 3 as a prime factor, and it needs to have an x plus 3 as a prime factor. To be a multiple of x squared minus 4x plus 3, I need an x minus 3 as a factor, but I've already got one. I also need an x minus 1 as a factor. So my least common multiple will be this product. There's good news. Unlike the case with numbers, it's usually best to leave your least common multiple in factored form. So if I asked you for the least common multiple of these two things, I would expect you to give me just this as the answer. I'm going to give you one of these to try. Find the least common multiple of these two polynomials. Pause the video and try this now. You can leave your answer in factored form. All right, we'll want to start by factoring each polynomial. This one has 1, 2, 3, 4 terms and no common factor. So I'll factor it by grouping. 2x to the 4th, 3x cubed, negative 16x, negative 24. Greatest common factor of this row is going to be an x cubed. Of this row, an 8, almost certainly negative. What times x cubed gives me 2x to the 4th? Well, 2x does. 2x times negative 8 is negative 16x. Sure is. What times x cubed is 3x cubed? Well, 3. 3 times negative 8 is negative 24. Yep. So this factors as x cubed minus 8 times 2x plus 3. But wait, there's more. What's this guy? Right, he's a difference of cubes. We can factor him as such. First factor will be x minus 8 is what cubed? 8 is 2 cubed. So we'll have an x minus 2. Second factor is every possible product of x and 2. X squared plus 2x plus 4. And then my remaining factor, 2x plus 3. All right, and now this is prime, this is prime. The trinomial we get when we factor a sum or difference of cubes is always prime. So this is prime. Next, we'll factor 2x squared minus x minus 6. Here we'll want to use the AC method. We have our 2x squared, our negative 6, and then we want two numbers whose sum is negative 1 and whose product is 2 times negative 6 is negative 12. A little bit of thought will tell us that we want negative 4x and positive 3x. All right, greatest common factor in this row, 2x. In this row, 3. 2x times x is 2x squared. 3 times x is 3x. So far, so good. 2x times negative 2 is negative 4x. 3 times negative 2 is negative 6. Yes. So this factors as 2x plus 3 times x minus 2. Oh, this actually looks really good for my least common multiple. My least common multiple will be, well, x minus 2 times this trinomial times 2x plus 3, and then to be a multiple of 2x squared minus x minus 6, I need a 2x plus 3 in my factorization, but I've already got one. I need an x minus 2, but I've already got one. So this is already my least common multiple.